Welcome to MRL. In this learning session, we'll be learning about algebraic identities. Before we begin learning about identities, let us understand as to what is an algebraic equation. An equation of algebraic expressions is an algebraic equation. An algebraic equation is true for a particular value of a variable. It means a particular value of variables satisfies the equation or makes LHS is equal to RHS. Let us understand this with an example. This is algebraic equation. It's a linear equation in two variables, x plus y equal to 7. Now if I put x is equal to 3 and y is equal to 4, then 3 plus 4 is equal to 7, 7 is equal to 7, LHS is equal to RHS. Therefore, particular value of x is equal to 3 and y equal to 4 satisfies this equation or makes LHS is equal to RHS. Therefore, x is equal to 3, y is equal to 4 are the only solutions which satisfy this equation. Let us take one more example. X plus 2 equal to 5 is a linear equation in one variable. If I put x is equal to 3, then 3 plus 2 equal to 5, 5 is equal to 5, LHS is equal to RHS. It means that value of x is equal to 3 is the only value which satisfies this equation. Therefore, particular values of x and y satisfy the equation or make LHS is equal to RHS, and that is what we see in algebraic equation. Now let us understand as to what is an algebraic identity. An algebraic identity is also an algebraic equation. Please understand this. An algebraic identity is also an algebraic equation which is true for any value of the variables. It means an identity is satisfied by any value of the variables. Let us take one example here. Now if you see here, a plus b square, a plus b whole raised to square is equal to a square plus 2ab plus b square. There is LHS, there is RHS, there is equal to sign. It means it is 100% an algebraic equation. Of course, it is an algebraic equation of second degree. Now if I put any value to a and b, if I put a as 1 and b as 1, and substitute on the RHS, we find that LHS is equal to RHS. Put different values of a and b, we find that LHS is equal to RHS. That means this equation, which is an algebraic equation, is satisfied by any value of the variable, and therefore it is called as an identity. So the difference between an algebraic equation and algebraic identity is an algebraic equation is satisfied by a particular value of variables, whereas an algebraic identity is satisfied for any value of the variables. Remember that. Now we have different important algebraic identities. A few of them I have listed here. There are only 14 of them. Very important identities. Try to remember these identities. Very useful in applications in mathematics. Now the first identity is x plus a into x plus b is x square plus a plus b into x plus ab. A plus b whole raised to square is a square plus 2b plus b square. A minus b whole raised to square is a square minus 2b plus b square. A square minus b square is equal to a plus b into a minus b. A plus b plus c whole raised to square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. A plus b whole raised to cube is equal to a cube plus 3a square b plus 3ab square plus b cube. A minus b whole raised to cube is equal to a cube minus 3a square b plus 3ab square minus b cube. A cube plus b whole raised to cube is equal to a plus b in the bracket a square minus ab plus b square, and this is factorization here. A cube minus b cube is equal to a minus b in the bracket a square plus ab plus b square. A cube plus b cube plus c cube minus 3abc is equal to in the bracket a plus b plus c, and again in the bracket a square plus b square plus c square minus ab minus bc minus ca. Very important identity. Now if you take three factors here, x plus a into x plus b into x plus c, there are three binomials product of three binomials, then we get x cube plus a plus b plus c, x square plus ab plus bc plus ca into x plus abc. A very important identity again. A cube plus b cube is equal to a plus b whole raised to cube minus 3ab in the bracket a plus b. A cube minus b cube is equal to a minus b whole raised to cube plus 3ab in the bracket a minus b, and a cube plus b cube plus c cube is equal to 0 under given condition that a plus b plus c equal to 0. So these are various important identities and very useful in mathematics, in every branch of mathematics. Remember that. And remember, to prove them, it's a very simple thing. Take the product of this, applying distributive property, we get RHS. Take the product of a plus b into a plus b, we get RHS. So therefore, the identities can be proved very easily by simplifying LHS and getting RHS. Let us take one example here. A plus b whole raised to square is equal to a square plus 2ab plus b square. If I have to prove this, then take LHS, that is a plus b whole raised to square. Then a plus b whole raised to square is nothing but product of a plus b into a plus b. Now apply distributive property. A in the bracket a plus b plus b in the bracket a plus b, we get a square plus ab plus b square, a square plus 2ab plus b square, which is equal to RHS, and that is how we can prove the identity. Similarly, all the identities also can be proved. Remember that. Now let us learn a few examples of application of identities. If I want to find the product of 102 into 103, I can directly go for product method, but here I want to apply algebraic identity. So let us see which identity can be applied. Now 102 can be written as 100 plus 2, 103 can be written as 100 plus 3. If you observe, the first term is same, second term and second term of both are different. Therefore the identity which can be used is x plus into x plus b. X plus into x plus b is x square plus a plus b x plus ab. Here x is 100, a is 2 and b is 3. Now substituting these values on the RHS, we get 100 square plus 2 plus 3 into 100 plus 2 into 3, that becomes 10,000 plus 500 plus 6, and that is 10,506 is the product of 102 into 103. That is how an identity can be used. Similarly, let us take one example, 99 whole raised to square. 99 square, take the product of 99 into 99, will get the product. But here we can apply the identity. 99 can be written as 100 minus 1 whole raised to square, and that is a minus b whole raised to square. A minus b whole raised to square is a square minus 2b plus b square, and identity here a is 100 and b is 1. Put the values on the RHS, we get 100 square minus 2 into 100 into 1 plus 1 square, that is 10,000 minus 200 plus 1, 9,800 plus 1, that is 9,801, and that is how we find out the product of 99 square using the identity. Let us take one more example, 103 into 102 into 98. So this is the product of 3 factors. So now if you want you can multiply directly by taking the product of the first two and again multiplying with the third to get the total product as 1029588. Instead of that, we can go for using an identity. And the unique thing is, now 103 is 100 plus 3, 102 is 100 plus 2, 98 is 100 minus 2. The first term is the same, 100, 100, 100, so that means it is x. And the second term is here we have 3, 2 and minus 2. So we can use identity x plus a into x plus b into x plus c. X plus a into x plus b into x plus c is x cube plus a plus b plus a x square plus ab plus bc plus ca into x plus abc. Here x is 100, a is 3, b is 2 and c is minus 2. Substitute in the RHS and get the value. So 100 cube becomes 1 followed by 6 zeros, and here 2 and 2 will cancel, we get 3. 100 square is 10,000, and 6 and 6 minus 6 will cancel, minus 4, minus 400 and minus 12. Now add this, that is we get 1029588. So that is how we can use the identity for finding out the product of numbers. So please remember that.